Okay, here we are on page 7. We already did the 5H from the beginning of page 7 in the previous video because it was a continuation of the previous problem. Now we're going to do this problem about trigonometric identities and law of sines. It gives us the sine of 13 degrees as 0.225. And then it says use one of the trigonometric identities to find the cosine of 13 degrees. Well, if you remember, the trigonometric identity that can be used for that is the sine squared plus cosine squared equals 1 trigonometric identity, which is derived from the Pythagorean theorem. We talked about this earlier in the mock exam. So basically what we know is if we have an angle, like the angle theta, and if we know at least one of the two, sine or cosine, we can derive the other one from this formula. And first of all, a notation thing. It's confusing to some people, this thing where you put the squared here, sine squared 13 degrees. This is actually equal to sine of 13 degrees squared. Okay, like when you put it in the calculator, you put it like this. Okay. So maybe what I'll do is, for now, I'm going to write it that way because maybe everybody will understand that way. Okay, but get used to it because in math, normally the squared is put after the sine or cosine, and that means the output of sine or cosine is going to be squared. Okay, so we know that the sine of 13 degrees is 0.225, so we're going to substitute that in. We don't know what the cosine of 13 degrees is, and we want to find out. And we know that adding the two together gives us 1. Oh, this is squared, right? Almost forgot that. Okay, so what is 0.225 squared? 0.225 squared is 0.0506. So I have 0.0506 plus cosine of 13 degrees squared is equal to 1. So now I'm going to subtract 0.0506 from both sides. So now I'll have cosine of 13 degrees squared is equal to 1 minus 0.0506. And 1 minus 0.0506 is equal to 0.9494. And if I just want to know the cosine of 13 degrees not squared, then I would take the square root of both sides, and that would be square root of 0.9494, which is 0.974. So now let's check that answer by doing it directly with cosine. Cosine of 13 is 0.974, so indeed it is the same. So you're saying, why didn't we just do that in the first place? Well, sometimes in math, we want to make sure that you understand how to use a relationship like this. And in some cases, like maybe you don't know theta, and this would be a way for you to figure out sine and cosine without having to figure out the angle first, which would be one extra step. Okay? All right, 6b. Use another trigonometric identity. Find the tangent of 13 degrees from the sine and cosine of 13 degrees. Okay. Remember that the tangent is equal to sine over cosine. And let's make sure that that's true. So tangent is equal to opposite over adjacent. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. So you can see that the h's cancel out here, and actually sine and cosine is sine over cosine is actually opposite over adjacent also. Okay? So that's why that works. Okay. So sometimes if you have sine over cosine, sine and cosine already, you can easily get tangent by dividing the two. So if we want to know tangent of 13 degrees, what we can do is we can take the sine of 13 degrees, which turned out to be 0.225. We know that from the earlier problem without putting it in the calculator. And we can put in the cosine of 13 degrees in the bottom, which is 0.974. Okay, so we put this in the bottom, and we put 0.225 in the top. And then when we divide it, we got the tangent, which is 0.231. Okay. let's confirm that by doing tangent directly. 0.231. Good. Okay. Now use different trigonometric identities to find the sine and cosine of 26 degrees. Now, it's not a coincidence that 26 degrees is exactly double of 13 degrees. Remember, we have all sorts of trig relationships where if you know the sine and cosine of an angle, you can also figure out the sine and cosine of the double angle just by using certain equations, okay? And I'm going to write the equations here, and you should put them on your formula sheet also. Okay, so the trig identities that we're going to use to find double angles are these 4 trig identities. Now, you don't have to use them all. Of course, when you figure out the sine of a double angle, you're restricted to just this one. Okay, so there's no other one you can use anyway. But when you do cosine, you can actually choose from one of these 3. Okay, and so like, for example, if you only know the sine of 13 degrees, you would use this one to figure out the cosine of 26 degrees. If you only know the cosine, you would use this one, of course. If you know both, you could go ahead and use this one. Okay? So usually it's easier to use one of these ones that you only need to know one of the 2. So how about if we just use, let's see, what do we know here? We know that the sine is 0.225, right? So why don't we use the sine one? We use this one. So we'll say cosine of 2x is equal to 1 minus 2 sine squared x, and remember sine squared x is the same thing as sine x squared. So here I'm going to put sine of 13 degrees, and if I put the sine of 13 degrees here, then this was going to be the cosine of 26 degrees, right? So that's how that's going to work. Now all I need to do is substitute in the sine of 13 degrees, which is 0.225. Okay, so it's 1 minus 2 times 0.225, which is 0.450. It's 1 minus 0.45, which is equal to 0.55. So the cosine of 26 degrees is 0.550. All right, what about the sine of 26 degrees? Now we're going to use this one. So the sine of 26 degrees is equal to 2 times the sine times the cosine of 13 degrees. So it's 2 times the sine of 13 degrees times the cosine of 13 degrees. So that would be 2 times the sine we know is 0.225, and the cosine of 13 degrees we just found out is 0.974. So let's figure that out. 2 times 0.225 times 0.974. 0.4383. Okay? All right. Let's check our answers. We're going to do sine of 26 degrees. 0.438, yep. And we're going to do the cosine of 26 degrees. 0.899. Oh, I forgot to do the squared. This should be squared. This should be squared. Sorry about that. Isn't it a good thing to do to check your answers? Did you guys already see that I was going wrong there, or did you just miss that like I did? I did the wrong thing. It's 0.225 squared. 0.225 squared. Okay, so we do 1 minus 2 times 0.225 squared, which is that. Okay, so now we got the right answer. 0.899. Okay, so the cosine of 26 degrees is actually is equal to 0.899. Okay, and the sine of 26 degrees is 0.438. And look at how we did that. We figured it out using the identities because we happen to know the sine and cosine of 13 degrees. Okay. 60. Now that we have the sine of 13 degrees and the sine of 26 degrees, use the law of sines to find the length of side B. Okay. Here we're going to use the law of sines, right? And the law of sines, remember, is you can either use this version, which is the sine of an angle. Big A is an angle. Small a is a side. Big B is an angle. And small b is a side. And remember that side small b is always on the opposite side of angle big B, and same thing with small a and big A. They're opposite from each other. Okay? And you could use it that way, or you could use it the opposite way. Okay? Whichever way is convenient. Which way is convenient? Well, if you don't know an angle, then you would want to use this format, because then your unknown angles in the numerator, you don't have to move it around, flip it over, anything like that. If your unknown is a side, then you would use this version. Okay? So let's see in this case what we're looking for. Okay, now that we know that the sine of 13 degrees and 26 degrees is such and such, use the law of sines to find the length of side B. Okay, so let's see what we want to know and what we know. We don't know this, but we want to know it. We know this, and we know this. Okay, so it looks like we know a pair, an opposite pair here. So that's going to really help us with law of sines, because as you can see, you have to know 3 of the 4 to figure out the fourth one. Okay? So in our case, we're looking for a side. So if we're looking for a side, it's more convenient to use this one. A little bit less algebra if we use this one. Okay? So I'm going to start plugging in variables here. And instead of having small a and big A and small b and big B, we actually have small c and big C. So I'm going to change one of these to be c's instead. C and sine of big C. Okay. So small b is unknown. We're going to leave small b. Sine of big B is going to be sine of 26 degrees. Small c is 5. And big C is 13 degrees, so it will be sine of 13 degrees. And we know the sine of 13 degrees is 0.225, so we're going to substitute it in. We know the sine of 26 degrees is 0.438. Okay, now what we're going to do is we're going to multiply both sides by 0.438 to isolate the b, and then we'll have something like this, right? And that gives us side b. So let's do the calculation on our calculator. 5 times 0.438 divided by 0.225. 9.73. So side B is 9.73 long. All right. 6C. From the corridor of room 17, Mr. Hayes looks down at the AC gatehouse with an angle of depression of 13 degrees. The height of his vantage point is 5 meters. Draw a sketch showing this data. Okay, so here's Mr. Hayes. He's standing outside of room 17, and he's looking down at the gatehouse here. Now, this is a horizontal line looking out from, oh, well, let's look out from his eyes. Okay, and then he's going to look down 13 degrees. Angle of depression means he's starting out looking horizontally, and then he looks down. The angle that he looks through is the angle of depression, so that's going to be 13 degrees. It says the height of his vantage point is 5 meters, so that means from the floor, from the ground to his eye level is 5 meters, so we're going to put 5 there. Okay, so basically we've drawn a triangle, and remember, like, this angle here is also 13 degrees. Okay. Because if you have parallel lines cut by a transversal, alternate interior angles are congruent, right? Remember learning that in geometry class? Okay, so that's our picture. Use the tangent of 13 degrees to find the distance across the parking lot to the gatehouse. Okay, so basically we're looking for this distance here. So tangent of 13 degrees is opposite over adjacent. Opposite in this case would be 5, and the adjacent would be x. So we also know that tangent of 13 degrees is 0.231, right? So we're going to put 0.231 here. And then we're going to say, okay, we want to know what x is. So we can cross multiply, and so we'll have 5 equals 0.231x. We just did that to get x in the numerator to do a little bit of algebra. Now we're going to divide both sides by 0.231 to get the value for x. So 5 divided by 0.231 is equal to 21.6. Okay, so that's our answer. The gatehouse is 21.6 meters from the building. Find the circumference of a circle with radius of 5. Okay. If you have a circle with radius 5, then the circumference is going to be 2 pi r, which is equal to 2 pi times 5, which is equal to 10 pi. Okay. Then it says, find the arc length of a sector of the circle that has angle of 57 degrees. 57 degrees. It's about like that. Okay. So how long is that arc length? Well, we can figure it out. The way we figure it out is we make a proportion. What's the degrees, the total degrees in the circle? It's 360 degrees, right? So I can say 57 degrees divided by 360 degrees is the proportion of the circumference of the circle. That is the blue length. So I'm going to multiply that times 10 pi. 57 divided by 360 is 0.158. So 0.158 times 10 is going to be 15.8. So the answer is going to be 15.8 pi. Okay, and that's a distance, right? Because it's part of the circumference. Okay. Last one. Find the area of a circle with radius 5. Okay, so we have a circle of radius 5 again. Now we're looking for the area. So the area is pi r squared, remember. It's easy to remember that pi r squared is the area because it's squared. So the area makes sense to be a squared of a length, right? And the other one, this one here, it's easy to remember that circumference or a length because it's not squared, okay? So pi r squared is equal to, in the case of r equals 5, is going to be 25 pi. Now, if I want to know a sector with an the area of a sector with an angle of 57 degrees, then basically what I'm looking for is, here's 57 degrees again, I'm looking for the area of this pizza slice. So how am I going to do that? Again, I am going to multiply by a fraction, which is going to be a proportion of 57 degrees to the total area or sector of 360 degrees. So I'm going to multiply that times 25 pi, and that's going to give me the area. 57 divided, I already know that that's 0.15, right? 0.158. And I'm going to multiply times 25. And I'm not going to multiply times the pi, I'm just going to leave the pi as pi. 3.96, so it's going to be 3.96 pi. Okay? And that's it, we're done.